Standard 10th Mathematics Part 2 Chapter Dealing with Trigonometry in Understanding Trigonometrical Ratios. Children, let's understand what is trigonometry. As the name suggests, it is all about triangles. More specifically, trigonometry is about right-angled triangles. As you can see on the board, triangle ABC is a right-angled triangle where angle B is equal to 90 degrees. Trigonometry is a system that helps us to work out missing or unknown sides, lengths or angles in a triangle. Now, let's understand where do we need trigonometry. As we already know, the study of trigonometry involves learning how trigonometric functions. The different trigonometrical functions that we have already studied in the earlier classes, we will definitely understand them. They were sine, cosine and tan. Trigonometry, where can be used in daily life? We know that trigonometry can be used to roof a house, to make the roof inclined, that is a slope in case of single individual bungalows, and even the height of the roof in buildings. It is used in naval and aviation industries. We also know that trigonometry is used in cartography, that is creation of maps. So, trigonometry has its own applications in satellite systems also. So children, let's understand in more detail how we can use trigonometry and how can we find out the ways of calculating different sides and measurements by using trigonometry. So now children, let's particularly consider a right angle triangle as shown on the board. Which angle is 90 degrees? Over here angle B is shown 90 degrees. So let's find out and recall the different trigonometrical functions that we have found out. Now let's remember that trigonometrical functions all will be dealt only for finding the values for acute angles in that right angle triangle. So if angle B is 90, which are the different acute angles in this right angle triangle? What is an acute angle? Acute angle is an angle which measures between 0 to 90 degrees. So in this case, which two angles are acute angles? One is angle A and the other angle is C, which can be said are acute angles individually. So children, over here, let's find out the different trigonometrical functions for these two acute angles. Which were they? First one was sine of any acute angle. So over here, what was the general formula for finding out sine of any angle? You can say sine of angle C. Over here it is labelled as theta. So sine of theta was given by a general formula. And what was that formula? It was opposite side upon the hypotenuse. Which was the second trigonometrical function. It was called as cosine of any acute angle. Now we are dealing with angle C, which is given by theta. So cosine, or it is also called as cos. Cos of which angle? Theta. Was given by which formula? Adjacent side upon the hypotenuse. And the third trigonometrical basic function was called as tan. Of which angle are we considering over here? Angle C, that is theta. That was given by a general formula, that is opposite side upon the adjacent side. To find out the values for all three, that is sine, cos and tan, particularly for this acute angle, by using this general formula, let's find out the values. So sine of theta is given by opposite side. So which is the opposite side for angle C or theta? It is AB. And which is the hypotenuse for this particular triangle? We know hypotenuse is the side opposite to 90 degrees. So it will be AB, opposite side, upon the hypotenuse, that is AC. So we get sine of angle theta. Let's move on to find out the cos value. What is the general formula? Adjacent side upon hypotenuse. For angle theta, we have two adjacent sides, but particularly AC is called as the hypotenuse. So which is the other adjacent side? BC upon the hypotenuse. Which is the hypotenuse again? As we are considering the same triangle, it is AC. Let's move on to find the tan ratio of the same angle, acute angle, that is opposite side of theta, that is AB, upon the adjacent side. So for angle theta, AB is the opposite side and adjacent side, as we already know, is BC. It's not written hypotenuse, so let's be careful of not substituting AC in the denominator. So the adjacent side for angle theta is BC. So by using the general formulas, we have found out the three basic trigonometrical functions for one acute angle, that is C, which is given as theta. So sine of theta, cos of theta, tan of theta. Now children, looking at the figure, we have one more acute angle for this triangle. Which is that? That is angle A. Now, logically speaking children, either you can write it as sine of angle A, cosine of angle A, tan of angle A. And by using the general formula, we can find out its values. But logically, again as I said, if this is theta, how much will angle A be? Definitely it will be, as both together are 90, A plus C is 90. If one angle is theta, the other one can be written as 90 minus theta. So let's find out all three trigonometrical functions for which angle? Angle A. How much is angle A? 90 minus theta. So this is the only change I will make over here. Sine of 90 minus theta, cos of again which angle? 90 minus theta, tan of which angle? 90 minus theta. Which angle is 90 minus theta? Angle A. Which type of angle is it? Acute angle. Which formulas will we use? The general formulas. For sine, it will be opposite side upon hypotenuse. For cos, it will be adjacent side upon hypotenuse. And to find the tan ratio of the same angle, it will be opposite side upon adjacent side. So, our values will change as our acute angle is different. Okay? So, let's find out sine of 90 minus theta. This angle. Again the same formula. Opposite side upon hypotenuse. So, that will be BC upon hypotenuse. That is AC. Right? Let's move on. Cos of 90 minus theta. Cos. Cos is what? Adjacent side upon hypotenuse. So, AB upon AC. And the last one, tan of 90 minus theta is given by which formula? Opposite side of that particular angle upon adjacent side, excluding the hypotenuse. Right? So, opposite side is BC upon its adjacent side, that is AB. So, here children, again we found out the three trigonometrical functions for the second acute angle, that was angle A. So first we found out for angle C the values of sine, cos and tan. Next, for the second acute angle, we found out again the trigonometrical functions sine, cos and tan. Right? Now children, let's move on. If we see the 6 answers that we got, let's find out the relation which we have already studied earlier. I will write down over here the first ratio, the second ratio and the third ratio, right? Sine of which angle? Theta. Cos of which angle? Again theta. And tan of which angle we found out? Again theta. What were the answers? Let me write it down. What was sine? Opposite side upon hypotenuse, that is AC. Cos of the same angle was adjacent side upon hypotenuse. And what was tan of the same angle? Opposite side upon the adjacent side, that is BC. This was for one particular acute angle, that is theta. What else we found out? We found out again the 3 trigonometric functions for the second acute angle of which right angle triangle? ABC. Let's pen them down and see what we get. The relation. Right? Again, sine of which angle now? 90 minus theta. Sine of the other acute angle, that is sine of 90 minus theta, cos of 90 minus theta, and tan of 90 minus theta. Now let's see what we get, children, using the same general formula. What was sine of any angle? Opposite side upon hypotenuse. BC upon AC. What was cos of any acute angle? That is, over here particularly we are referring to 90 minus theta. So cos of this angle will be adjacent side upon hypotenuse. Which is the adjacent side? AB upon AC. Tan of 90 minus theta is opposite side upon adjacent side. Opposite side BC upon adjacent side. Opposite side upon adjacent side, that is AB. Now children, let's look at the answers that we got on the board. Sine, cos and tan for one acute angle. Sine, cos, tan trigonometric functions for the other acute angle. If we look at them, the values that we get, we see that sine of one angle, its value is equal to a trigonometrical function of the other angle. So let's look and check what we get. We see that sine of one acute angle, that is theta, is AB upon AC, which is equal to the same answer for cos of the other acute angle, that is AB upon AC. Let's see the next one. Cos of theta, that is BC upon AC, was equal to sine of the other acute angle, BC upon AC. So children, what can we conclude? We can conclude that sine of one angle is equal to cos of the other acute angle. The answers are the same. So if we find out sine of one angle, that answer is equal to cos of the other acute angle. Cos of one angle is equal to sine of the other acute angle. And what about the tan ratios? We see that they are reciprocals of each other. If tan of one acute angle is AB upon AC, then tan of the other acute angle will be BC upon AB. That means they are multiplicative inverses of each other. Right? So thus what can we conclude? We can conclude that sine of one angle is equal to cos of the other angle. Cos of one acute angle is equal to sine of the other acute angle. And what about the tan ratios? They are multiplicative inverses of each other. That means if I multiply tan theta into tan of 90 minus theta, what do we get? Let's check. Tan theta into tan of the other acute angle. Which is the other acute angle? 90 minus theta. Let's see what answer I get. What is tan theta? What is tan theta? Opposite side upon adjacent side. AB upon BC. What is tan of the other acute angle? Same formula. Opposite side upon adjacent side. BC upon AB. So finally what do we get? They get reduced and the answer is equal to 1. So what did we learn, children? What is the relation between the acute angles for the trigonometrical functions? Sine of one angle is equal to cos of the other. Cos of one acute angle is equal to sine of the other, and the product of the tan ratios of both the acute angles, the product is always equal to 1.